9 weeks, so those of you who didn't do so well last 9 weeks, starting off with, everybody's got 100 right at the moment. Look at problem number, let's do 16. Look at problem 16. Have your calculators out so you can help me with some of this if we need them here in a second. Do some of the multiplying and stuff. My fault, I already. Anytime you see a problem like this, put parentheses around those two parts because they have more than one thing in that term. So any of the problems that are like that, put parentheses around those. You cross multiply, we're going to write this down. And again, I know there's several of you in here that are going to say, Ebersole, we don't need to write all that down. We could do it in our heads. That's fine if you think you can do that, but I'm telling you, my 30-some years of teaching, I see more students who make a mistake trying to do it in their heads when it took me, what, 4 or 5 seconds, 6 seconds to write that down maybe. Doesn't take very long. Write it down, then worry about it.
Good morning. Will you please stand for the Pledge of Allegiance?
I will.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
While they're doing announcements, if I still have your binder, it's laying over here, grab it. Don't leave it lay there.
If you're planning to take CCP courses at National Trail or through a college, you must turn in the intent form to Mrs. Brower by April 1st. Those forms are in the high school office.
Just listen to what they're telling you.
Any girl planning to attend prom this year and needs help with a dress, please see Mrs. Dunn. Today's menu is chicken tenders, mashed potatoes, fruit and milk, hamburgers, and one-trip salad bar will also be available. And happy birthday today to Jonathan Wilson. Have a great Thursday.
Jacob, if you need a dress for prom, just let me know. I used to be about your size, so I have a few.
Can I get one?
You're too young to go to prom.
I just blend all of what am I paper? Can I go? I know.
Next, what's this give us when we distribute here?
5 bar plus 25.
No, the stuff we're getting in, plus 25. Shh. All the extra chatter, I ain't gonna put up with it anymore. It's getting too late in the year. So if you wanna get a detention, then that's fine. Keep talking behind me and say, I wasn't talking. Then you'll have that argument with Mr. Eiler, because I'll write up, I didn't say anything. Did I say anybody's name?
No.
Then Kellen, don't, because now I'm saying your name. Because when I write it up, I'm sorry, but maybe Hannah wasn't doing anything. Now I give her a detention. She goes down and talks to Mr. Eiler. Who's he going to believe? Probably me. Just to let you know that.
But there's multiple.
Next one.
Sorry.
What's this give us?
8R minus 72.
Now what?
These parts.
Minus 5R. Please remember, get all the variables on one side before you do the other stuff. I'm not sure why so many of you want to get the regular numbers together first, because it ends up confusing you. Some of the times, not all the times, but some of the times. Got 8R minus 5R, what's that leave you with?
3R.
Now what?
Add 72. Sorry. Just 93.
90 what?
97.
97 equals 3R.
Yeah.
Now what?
Divided by 3.
Grab your calculator. Don't write down the answer that you're going to tell me here in a second, because I don't want it. You grab your calculator, you divide 97 by 3. Does it come out all nice and even?
No. It's just 32.
All right, so when you do it, when you do it on your calculator, look at the whole number. What is the whole number?
32.
32. Anytime you're dividing by 3, those are a couple of the ones that we talked about last time. If it's the 0.3 repeating, what is that as a fraction?
1/3.
1/3. That's the answer I'd rather see.
What about 97 over 3?
Yeah.
You could leave it 97 over 3. I don't like this answer,
I got it.
because once you get to a certain point, and you got to use a little common sense here, If I tell you 97/3, that tells Cameron absolutely nothing. If I tell you 10/3, he can understand that. But 97/3, that doesn't mean anything to anybody really. You don't know how many, there are there, and it doesn't really tell you anything. 10/3 is all right to leave this way, because 10/3 makes a little more sense, or something like 5/3 or whatever. But when you 3/2, stuff like that, it's all right to leave it that way because that makes a little sense to anybody who looks at it next. But if you're looking at 97/3, yeah, that doesn't make any sense to anybody. All right. So when we get to big numbers, if we get to something like 567/3, no, I don't want it left that way because that makes no sense to nobody. All right. So you need to change that into a mixed number of some kind. Everybody think they could handle all the proportion stuff? Nothing hard about it? Everybody can handle proportions? Those are probably the hardest ones that we're going to do, making sure you set them up right and stuff.
How did I get that so long?
That's what you said.
Probably.
I wasn't looking at the bowl.
It came up so fast.
Do you remember last time what I had to do with Branson? I had to take pay
yeah.
attention to what we were doing, and then he wonders why he gets something so wrong.
I did everything right though. I just got the wrong answer. I messed up.
Look at the packet, on the packet. Number 1, look at number 1. First thing they want you to find is the scale factor. So we want to find the scale factor. Notice the arrow tells you which way we're going this time. So are we getting bigger or smaller?
Bigger.
We're getting bigger, so it's an enlargement. So our scale factor should be bigger than 1. If it's not, if we come up with something like 2/7, then we messed up somewhere. All right? Pick me a side in the first triangle.
30, or not, that's the first triangle, 13.
13. Does it matter which one you pick? Not as long as you can match it up to something in the second triangle. What's it match up to in the second triangle?
39.
39. That's our scale factor. Now with scale factor, again, you might want to grab your calculator and use the ABC button, or if you have the big calculators, the math button, and reduce it down. So
That's wrong, isn't it? Because aren't you supposed to put the new over the old?
now they tell you the arrow here.
I know, aren't you supposed to put?
Oh
new over
yeah,
old?
you're right. My fault. My
Isn't it
fault.
supposed to be 39/13?
So it should be 39/13 because what are we getting?
An enlargement.
We're getting bigger. My fault. Thank you.
Yep.
3.
So 3. Now, if we want it as a scale factor, it probably means 3 over what? 1. If you leave it that way, that's fine. If you left it 39/13, that would be fine also.
Yeah, I'm getting it.
Second part. On this part, they want you to just match up the angles. Match up the angles. So pick me an angle in the first triangle. Angle what? You can name all these
D.
with one letter.
MLN.
Just one letter.
D. Oh wait, are we the first one? MLN.
One letter.
L.
Nobody's listening. All right.
L.
One letter. I'm sorry, Hannah. Some people aren't listening.
L.
L. Thank you. So angle L. Angle L matches up to what in the second triangle? Angle Q. Make sure you're using your symbols. Go ahead and do the other 2 angles, the other 2 pairs of angles. They're on those next 2 blanks.
Does it have to be the angle? Or do we do like the line?
No, there's a line.
No, the segments are the bottom part here. So we're matching, for the first 3, we're matching up the angles. What other angles did you get? I'm not gonna write them down, but you can tell me.
Angle M and angle R.
Angle M matches up to angle R. What else?
Angle N.
Angle N matches up to angle S. Please make sure you're using your angle symbols. And some of you lose points on the test for no reason other than you're not putting your symbols every time. Now, the next part, we're just gonna match up the size. Since we're doing scale factor and we wanna go new to old, let's go that way. We already know one of them. What was one of the two sides that matched up?
39/13.
39 to 13.
18/6.
If you put the bigger triangle on top, what has to be on top all the way across here?
Bigger triangle.
Bigger triangle and the smaller one on bottom. So what's the next one?
18/6.
Everybody agree with that, 18/6? And next one,
30/10.
everybody agree with that?
Yeah.
If we reduced each one of those, what's it gonna reduce to? 3 over 1. What's this one reduced to? 3 over 1. What's this one reduced to? 3 over 1. If we reduce them that way, every time it's gonna come out to be the scale factor. Alright? Which question, Grace?
Who are you twinning with?
On the next page, look at the next page. Says find the value of x. This is what we're going to be doing today. We look at these two triangles. Look at number 4 here. This is part of what we're going to be doing. We want to find that missing part, what you're going to do every time. This is exactly what the homework, and the homework's very, very long, so we want to make sure that we have plenty of time to get started on it while you're in here. When we do this, we're just going to match up stuff, so we set up these proportions. Whenever you match up something from the first triangle to the second triangle, the first thing you want to do in this first ratio is try to make sure you have 2 numbers. Don't put a variable in the first ratio if you don't have to. All right, put it in the second ratio. Because otherwise, sometimes you'll end up with 2 variables in a problem and then you can't do it. Pick me a side, or 2 sides, one in the first triangle, one in the second triangle, that match up that we know numbers for both of them. 12 and 8. Everybody agree with that? 12 and 8?
Yeah.
Now, the variables, is it in the first triangle or the second triangle? First triangle. So is it going to go on top or on bottom? On top. This 12 came from the first triangle, right? So that means that the x is going to go there. What's the x match up to in the second triangle? 15. Now what do we do to solve this? Cross multiply. Now before we cross multiply, to try to help you out, some of the times you can make this easier on yourself by reducing this. What's a number that will go into both 8 and 12?
4.
4 will. How many times will 4 go into 8?
2.
How many times will 4 go into 12? Now when we cross multiply, what's this give us?
2x.
When we cross multiply this way, what's that give us? 45. Some of you can probably do that in your head, right? Whereas 12 times 15, I'm venturing a guess that you probably couldn't do in your head. But 3 times 15, you can. Now what do we do?
Divide by 2.
Divide by 2. Does that change our answer when we reduce that down? Is that going to make our answer different than what it would have been? No. What is 45 divided by 2? You can give me the decimal answer this time. How come I said you can give me the decimal answer?
It's one place.
It just goes out one place, it comes out nice and even after that one place. Nothing wrong with that. The ones I don't want to see as a decimal are the ones where it's something repeating or something where it just goes on and on forever. All right? Look at number 14. 14. You're building a roof on a garage. I made up this problem here a few years ago because I was actually doing this. Except mine's backwards from this because it was a barn. So my barn is the bigger one. My house was the smaller one. My wife wanted it to match up perfectly with between the house and the barn,
It's a big barn.
look the same. You're building you're building a roof on a garage such that the gable of the house is similar to the gable of the garage as shown in the diagram. The gable is just, you got your house sort of looks like this. It's a rectangular prism maybe. It looks like that. The gable of the house is that part that comes up as a triangle and sticks off the two ends of the house, or whichever it is. That's the gable.
Okay.
The area of the gable of the house is 3,024 square feet. Find the area of the gable on the garage. Again, mine was backwards to this, but we had, last time in the notes, we had a formula that said area of the first shape compared to area of the second shape should equal what over here? Was it just a side of the first shape?
Yeah.
What do we have to do to it?
Side of the second shape.
That's true, but was that it? It's just that way?
Wasn't it? Weren't they both square?
You had to square them both. All right, for the area theorem, you had to square both the sides. For the perimeter ones, you didn't have to square them, it just matched up. Do we know the area of the first shape?
No. Yeah.
What is it?
3,000.
3,024? Do we know the area of the second shape?
No.
Why might we want to know the area of the gable on the barn? Or on the garage?
That's what it's asking for.
You're gonna need that much siding.
If we're putting siding on it, then we need to know that, right? And when we did ours, what happens on our house is you have the bottom siding, and then you'll see it on a lot of houses. As you go up, when you get to the gable, it changes to something else to sort of break up the monotony of the house. So, this siding going across here is one thing, and then the siding up here might be like a rock style or something, it might just be that rock looking thing, like fake rock looking something.
What is monotony?
Monotonous, it's like monotonous means like
The same.
Branson asking me the same questions over and over every day it'd be monotonous. It's when I give you that look. Are you kidding me? I just answered that 6 times.
Come on, baby.
Pick me a side. Now, they didn't really tell us a side. Pick me what they did tell us, though, in the first gable. What did they tell us about the house gable? Anything?
It's 42 feet tall.
42 feet. We got to square that and
14 squared.
14 squared on bottom. Do this first. Grab your calculator. Somebody help me out and tell me what 42 squared is. 764? What's 14 squared?
196.
Now, when we cross multiply, another thing that might help you out, when you get some of these big numbers like this, and you probably don't want to write them down like I do every time, you cross multiply this way, and we cross multiply this way, these two are going to get multiplied together. What are we going to end up doing with this one?
Just add.
Dividing it.
Dividing by it. So multiply these two. Go ahead and do that on your calculator.
Couldn't we just reduce it now?
You could try to reduce it. I don't know.
It reduces to
192,000.
So we'll go back to that here in a second. So you got that answer on your calculator, right? Instead of writing it down, you know that the next step is you got that times that. Well, that's just 1764 times A.
330.
You're going to divide both sides by that 1764, right? So once you have this number on your calculator, divide by that number. What's it leave you with? 336. What's our units?
Feet.
What was it?
Feet.
Just feet?
Yeah.
What's the A stand for? Area, so it's feet squared. Does it make sense that that garage gable is gonna have an area of about 336 square feet? Yeah. Now, what Jacob said over here, and you could try this on your calculator, if you get big numbers like this and you don't want to punch them into your calculator all the time, could you try to reduce that down?
Yeah.
Yeah, using the ABC button or the math button on your calculator. Do that. Grab your calculator and hit the 1764 ABC button, 196, and hit
9.
enter.
Yeah, 9/1.
So it just comes out 9/1. Then when we cross multiply, you get 9 times A equals 1 times 3,024. Now we just divide both sides by 9. What's 3,024 divided by 9?
336.
Same answer. So you could have reduced it first, if it'll reduce. If it won't reduce, then you gotta go back and do it all again. That's up to you if you wanted to check that. If you didn't grab the notes up there, grab them real quick. Second set of notes for this 9 weeks.
Yeah, remember that thing I said I did, but I couldn't find it?
Okay, I
Yeah,
still
if
need
it's
to
up
find
there
it.
with your no name on it.
Yeah, I got it. So, extra credit.
You want the worksheet
Yeah, I'm
down
gonna give you extra credit for not putting your name on it.
I did it twice.
That. Is that Ebersole's fault? Alright, just want to make sure that we were
I was.
in agreement. Proving triangles are similar. This is the first thing we're going to do. Dealing with proving triangles are similar. We're also going to go over some ways, real world things that you would use this for. This is stuff, and I know Mason back here says it all the time, that, well, you use it because you're a math teacher. This is stuff that I use out in the real world constantly. Now, maybe none of you ever will. I don't know. You know, it might be that all of you are a little wimpy and don't build anything yourselves or do any of the work around your house. Once you get out of here and get married, you don't do any of it yourselves, and you'll never do it again. If you're sort of punkified that way, I should start that.
I built a whole deck in my house.
Yeah.
I do that all the time, for real.
Elizabeth, you had that look like you didn't buy that for a minute.
Don, you know who I heard actually does that?
I, this is probably what happened. Branson's out there helping build this deck.
Give me their
Why are we doing this? Why are we, what? I don't understand why, what? And finally, whoever's building the deck goes, just go away.
I do that too. It's a good strategy, honestly, if you want to get out of work. Just annoy them and they don't
Or
want you to
just
do
do
that.
it, get in trouble.
I'm clearly joking, Terry. Terry, you're here. I need your kicks.
No, I have.
You're here.
Oh, here.
Fill in what you need to fill in on this one.
I don't anymore. It's the other hand.
Okay, where's my day?
To make two triangles similar, or to have two triangles that we know are similar, to prove that they're similar. Unlike proving that triangles are congruent, to be similar, we don't have to prove near as much. So the easiest way, and the way that we use 99.9% of the time, is AA. What do you think AA stands for?
Angle, angle.
Angle, angle. So if you can prove one pair of angles are congruent, then another pair of angles are congruent, that means the two triangles are similar to each other. Not congruent to each other, but similar. So two angles in one triangle are congruent to two angles in a second triangle, like we have right here. Angle L is congruent to angle E. Angle A is congruent to angle R. Then we know that the two triangles are similar. We had another theorem earlier this year. Usually, I teach this theorem first, which I quit doing a couple years ago. Anybody have a guess what theorem that is? Angle, angle, angle. So if you prove all three angles in one triangle are congruent to all three angles in another triangle, then the two triangles are similar.
Oh, we have two angles.
We don't need this because we have the two angle theorem. All right? We said we had a theorem a while back that said if this angle is congruent to this angle is congruent to this angle, what has to be true about that third pair of angles?
It has to be congruent.
They have to be congruent to each other. So instead of doing all this, it's easier to just do this. We're probably going to turn them into that if you guys, probably not for my other classes because they don't get on my nerves as much. So don't get on my nerves and Branson's getting ready to tell Branson not to ask questions that don't have anything to do with what Ebersole's doing right now. Otherwise, he's going to get on my nerves and we're going to do a whole bunch of two-column proofs.
Hey, Branson, don't ask questions about stuff we're not doing right now. Let's get on the nerves. We have two people first.
Next one, find this. These are the kind of pictures you're going to end up with. And they're going to want you to know which triangles are similar to each other. First of all, the first picture. How many triangles you see in that first picture?
Three.
Three.
Two.
2, 3? Which one is it?
I see two. I
Oh,
see two.
oh yeah, two.
2?
The other one's quadrilateral.
So, one of them. Name the small triangle for me. What's up here?
ABE.
ABE. Does everybody see that? The bigger triangle. You might, I'm telling you right now, you might want to split them off that way as we're doing some of these problems. Separate them so you can see them apart because otherwise you end up getting confused.
Oh.
What do we know about this angle right here?
They're congruent.
So that's 52, and then this one is 52.
And we know that A is congruent because they're the same.
So angle A,
Oh.
if these are my two triangles, this is sort of what I'm looking at here. These are my two triangles. What do I know about this top triangle, or this top angle in the two triangles?
They're
They're
congruent.
the same.
It's the exact same angle in both triangles. All right? So we know angle A is congruent to angle A. Is that enough to say the two triangles are similar to each other?
Yes.
Somebody name the top triangle for me.
ABE.
Make sure you're using your symbols. And we know it's similar, not congruent. We know it's similar. Then you got to match up the other triangle. What's A in this triangle match up to in the other triangle?
A.
A, good. B in this triangle matches up to what in the other triangle?
C.
And then E in this triangle matches up to what in the other one?
D.
Those are the two triangles that are similar. So when I go to set up a proportion, what we're going to do later on in class, when I go to set up a proportion, segment AB in the first triangle matches up to what segment in the second triangle?
CD. BE.
Segment AB in the first triangle matches up to what in the second triangle? Does everybody see that? You can look at the names and see how they match up. So segment AE in the first triangle is going to match up to what in the second triangle?
AD.
AD. And we're going to match them up that way. Next one, how many triangles in this picture?
2.
2. What's these arrows tell us?
They're
Parallel.
Parallel.
Parallel. So if they're parallel, as soon as you see that they're parallel, what should you look for?
alternate interior.
So if I draw this, what do I know about those two angles?
Congruent.
They're congruent. So mark those two angles congruent on your picture.
Did you prove all three all right?
Yep. And we could go the other direction and do the other alternate interior angles. I'm not going to, because what do we know about this pair of angles?
Congruent.
They're vertical angles, so they have to be congruent. Is that enough to say the two triangles are similar?
Yeah.
Name the top triangle for me.
FHD.
Is everybody all right with the way Kellen named it?
Sure.
You got to be careful. Bunch of you on the last test screwed this up. All right, not last test, chapter 5 test. You messed this up. On the chapter 5 test, when you had to match them up, you got to make sure you're matching them up correctly. The F up here that we put first matches up to what in the bottom triangle?
Okay.
The K. A lot of you were just like flipping it over and matching it up, and that doesn't work this time. It's got to rotate around to match them up. The H in the top triangle matches up to what in the bottom?
H.
And the G in the top matches up to what in the bottom?
Yeah.
Okay.
On this next one, I'm going to draw it off to the side over here. How many triangles in this picture? There's 3.
Yeah.
This one's a little tougher, and there's actually a theorem about this, and it's called the altitude theorem, because this right here is called an altitude. If you have a right triangle and you draw an altitude to the hypotenuse of that right triangle, all 3 triangles, the 2 smaller triangles and the big triangle are always going to be similar to each other.
What's that called?
It's called the altitude theorem. And it's one of those things, remember when I said we skipped a couple of things? That's one of them that was in chapter 6 that we sort of skipped over. So, in that theorem, you look at these 3 triangles. If I draw the 2 smaller triangles, they look like that. And then I have the bigger triangle, looks like this. Help me out here. In the smaller triangle, what's this? What? It's,
Oh, L.
it's L, and it's 58 degrees. We'll write them both at the same time. What's this angle?
And it's 90 degrees.
M, and it's 90. Name this one.
32.
It's 32 degrees, and what's the name of it?
P.
P. How'd you know it was 32 degrees?
Because, I mean,
3 angles of a triangle have to add up to
180.
180.
And also the 58.
What's this angle? How many degrees? 90. What's the name of it?
M.
M. This angle?
58.
58. Everybody agree with that? And what's the name of it?
Well, we probably should have named that something else, the other one.
Nope.
The other P.
P.
Yeah.
All right. What's this one? How many degrees?
32.
32. What's the name of it?
And
N. Now let's go to the big triangle. What do we know about this angle in the big triangle?
90.
90. What's the name of it?
P.
P. This angle, how many degrees? 58. What's the name of it? L.
32.
32. How many, or what's the name? Those are our 3 triangles. Here's where you have to be really, really careful. And what Kellen was saying is we should have named it something else. You can't name it something else because what's that point right there? What's it labeled?
No, I mean, we should name it like LPM so that you know that it was that angle, and then.
Oh, I see what you're saying. So
Yeah.
instead of naming the angle with just P,
Because
name
some
it
people
with.
could see that and say, well, they're the same angle,
Right.
so they're congruent, but they're not.
And that's where you got to be careful when we go to. Go back to my other pen. When we go to say which ones are similar to each other. Somebody name this triangle for me.
LPM.
LPM. Everybody all right with the way he named that?
Yeah.
And it's similar to, now here's where you gotta start being careful.
PNM.
The L in this one matches up to what in this one?
P.
P. Does everybody agree with that? Yes, no, maybe?
Yeah.
This is 58, the P in this one's 58, so that's why they match up. The P in the first one was 32 degrees. What's it match up to in this triangle?
N.
N. And then the M in this triangle was 90 degrees. What does it match up to in the other one?
M.
M. Now, all 3 of these triangles are similar, so we're going to have another triangle similar to that. Sorry, I'm just trying to squeeze it in here.
And then we can do L.
Let's
N,
go.
P.
Let's do this one, the second one, and this one. The P in this one was how many degrees?
58.
58. What's it match up to in this one?
L.
L. The N in this triangle was 32 degrees. What's it match up to?
The N.
N again. And then the M was 90 degrees. What's it match up to in this bottom one?
P.
P. I'm going to rewrite that triangle. L, N, P. So all 3 of those triangles are similar to each other. And that theorem is actually A lot of books, it's actually called altitude to hypotenuse. Whenever you draw an altitude to a hypotenuse in a right triangle, you're gonna have three triangles formed and all three
Are
of them
they
are
always,
similar.
is that always called the altitude?
Yeah, altitude is,
Is it only in a right triangle though?
nope, altitude, so if we had this triangle and we drew this in,
Is that altitude?
that's an altitude. Altitude is the height of the triangle.
Okay, so it's from the corner to the other side.
Right, corner to the other side and it forms a right angle. Fill in what you need to fill in on this. These are two other ways to prove the two triangles are similar. Caitlin's gonna be upset with me here in a second. You all right with being upset with me, Caitlin?
Oh man, the music's gone.
Yeah, when it flashes like that, then it won't come back on when I go backwards. Notice the first one, SSS, but then what's it got at the end?
Similar.
The similar. So that's keeping it separate from when we were proving triangles were congruent by side, side, side. So what it says, if all the sides in these two triangles match up so that they're all proportional to each other, so they all make the same ratio, then the two triangles are similar. Pick me a side in this first triangle.
6,
What's it match up to in the other one?
3.
Pick me a side in the first triangle.
8,
What's it match up to?
4,
Pick me a side in the first triangle.
10,
What's it match up to?
5.
Now, for these to be similar, what has to happen here is all three of those ratios have to be equal to each other. What's this ratio reduced to?
1 over 2.
Close.
2 over 1.
2 over 1. What's this one reduced to?
2 over 1.
2 over 1. How about this one?
2 over 1.
So that tells us that these two triangles are similar to each other. The bad thing about this one, if we know all the sides, there's not really a whole lot to do with the triangles, because usually if we're dealing with triangles, we want to find the length of one of the sides. All right?
Does this mean we're going to have to use Pythagoras theorem a lot?
Some. On the next one, side angle side similarity theorem. So if we can prove that two of the sides match up and
The angle between.
the angle between matches up, then the two triangles are similar to each other. This is what I'm going to tell you. I sort of hinted on it here. This theorem, not real useful unless we're looking for angles. All right, which most of the time we're not. Most of the time we're looking for segments. So not real useful. This one, not real useful either. 99.9% of the time, we are going to use angle to prove the two triangles are similar. So those two, I'm showing them to you, Cameron, but we're probably not going to use them. On this one, we're going to do a whole bunch of this together, so find this on your paper. Stuff you should have went over last year in algebra. You might remember some of it, you might not. That's why we're going to go back over it.
Don't you like, isn't this like where you have the thing outside of
So-
the
yeah.
radical?
Some of your calculators, if you have like the Casio calculators that I don't like, if you have a Casio calculator, a lot of times it'll do this for you.
Thing straight through.
So simplifying radicals. Do we have, did I write that down for you? We wrote this down earlier this year, perfect square numbers. So if you take the square root of 4, what's the square root of 4? 2. You take the square root of 25, what's that? 5. Take the square root of 81.
9.
9. These are all the numbers that come out even, not all of them, because I stopped the list at 400 out so far, right? Otherwise, you get higher than 400, you're probably going to have to grab your calculator and figure it out anyway. What you're going to do to simplify radicals, and we're going to go through this sort of quickly, so you've got to watch closely. You're going to try to figure out a perfect square number that'll divide evenly into that 75. It's called the radicand, the number under the square root. What's a perfect square number up here that'll divide evenly into 75? 64 will divide evenly into 75? 25 will? Everybody agree with that? So this is what you do, and this is what I want you to write down on your paper. You break this apart into two square roots. Square root of 25 times, how many 25s are there in 75?
Three. And then you know the perfect square, right? So you just put 5.
What is the what is the square root of 25?
5.
So when you're doing this, you're looking for that number so you can take that part out from underneath the radical. It's no longer underneath the radical, and now it looks like this. 5 outside, what's still under the radical?
3. Square root.
That's your answer.
Whoa.
It's like simplifying or reducing a fraction. You're simplifying that radical to that. Next one. What will this one break into? What's a perfect square number that will go into 18 evenly?
9, 2.
9 and 2. What's the square root of 9? So that comes outside. What's still inside? 2. Do this for me on your calculator. Somebody take the square root of 18. Just type it in, square root of 18 on your calculator. Sort of remember that number. All right? Now do this. Take 3 times the square root of 2. They gave you the, do you have a Casio?
You're up at 2.0.
Now, some of the times, it gives you the same thing, right?
Yeah.
Now, on the cast, some of the times we want the decimal answer. So, do you know how to get the decimal answer?
You told me.
Oh, that's right, I did teach you that earlier. We should have.
If I put the decimal answer, I just put like 0.0 after the 2 and it gives you the, like if you're doing a square root, you put like 3 square root 2.0, it'll come out as a decimal because it reads the decimal and so it is. Oh, well, he wants a decimal.
Next one. On this next one, what you're going to do with something like this, first thing, we'll deal with the top. Any perfect square number going to 12 evenly? 4 times what?
3.
What is the square root of 4?
2.
So you got 2 times the square root of 3 on top, and you got 2 on bottom. You got to be careful when you're doing these kind of problems and you're reducing it down. The 2 here and the 2 here, they're both just regular numbers, not numbers under the square root, so they can cancel out. So what are you left with?
Square root 3.
Just the square root of 3. If the 2 have been under the square root, they won't cancel out. So in other words, if you have something like this, square root of 2 over 2, you can't cancel these 2's out because one of them's not under a square root and the other one is. So that won't work. But when they're both outside, you can reduce it down that way. Rationalizing. A lot of books no longer do rationalizing. So on like the EOC test or something, they may rationalize, they may not. I don't know. But a lot of books don't. It's just like reducing a fraction. A lot of books thought, oh, that's too hard to teach Riley how to reduce a fraction, so let's just skip over it and just let him leave it as 2 over 4 instead of have to reduce it down. All right, which question, Riley?
What is the EOC test?
When?
Yeah.
May 2nd, something like that.
Is that our end of the year?
Yeah. So on this, what rationalizing does? You cannot have a radical in the denominator. Mathematically, just like your teacher told you, you should always reduce fractions down. You shouldn't leave a square root in the denominator of a fraction. So what you do to get rid of that, and this is what I want you to write down on your paper there. Whatever this square root is, you multiply both the top and the bottom by that square root that's on the bottom. So we multiply the bottom by square root of 2, we multiply the top by square root of 2. When they're both square roots, you can just do the multiplication. So I'm gonna come over here and write it. On bottom then, what's 2 times 2?
4.
So you got the square root of 4 on bottom. On top, what's 2 times 12?
24.
24. So you got the square root of 24 over the square root of 4.
And then
What is the square root of 4?
2.
So on bottom, we no longer have a square root on the bottom, now we just have 2. That's the whole purpose of this. On top, you need to break that apart. Any perfect square number that'll go into 24 evenly?
16, 4.
4 times what?
6.
So we're gonna break that into the square root of 4 times square root of 6. What is square root of 4? 2. Square root of 6 is just gonna stay the square root of 6. Will that simplify any farther?
Yes. You cancel the 2s.
You cancel the 2, so what are you left with?
Square root of 6.
Square root of 6. Now, what I want you to be careful of is you see how it looks like, oh, I could have just divided right there and got rid of it. Sometimes that works, sometimes it doesn't. So the way I'm showing you is the way you should do it. Next one. Didn't we already deal with the square root of 18?
Yeah.
What did it reduce down to?
3 square root of 2.
3 times the square root of 2. So let's just do that. And we still got square root of 2 on bottom. We're going to multiply by the square root of 2 on top, square root of 2 on bottom. What do you think? 3 times the square root of 2 times the square root of 2, what do you think that gives you?
3 square root of
3 times the square root of
4.
4. On top. On bottom, what's square root of 2 times square root of 2?
Square root of 4.
Square root of 4. On top, you got 3 times the square root of 4. Well, what is the square root of 4?
2.
2. So you got 3 times 2 on top. On bottom, what's the square root of 4?
2.
2. What is 3 times 2?
6.
6. So you got 6 over 2. What's that reduced to?
3.
Just 3 or 3 over 1. So your answer there is just 3. Sorry, I ran out of space there. So all of this, that whole thing right there, just reduced down to 3.
Dang.
Next one, what do we multiply the top and the bottom both by?
3.
Square root of 3. Square root of 3. Somebody help me out. What's on top?
42 square root of 4.
Everybody agree with that? Yes, no, maybe? 3 times 14 is 42. Is that right? Yes, no? It is. On bottom, what's the square root of 3 times square root of 3? Square root of 9. What is the square root of 9? 3. So on bottom, we got 3. On top, square root of 42. Any of those perfect square numbers divide evenly into 42?
No.
How can you check to see? Just go through and divide. So let's try it. What's 42 divided by 4?
Decimal.
42 divided by 9.
Decimal.
42 divided by 16.
Still decimal.
42 divided by 25.
No.
36. And once we get 49, we're too big, right? So nothing will go in there evenly. So what stays on top?
40 square root of 42.
Square root of 42 over 3. When you're doing square roots and you're multiplying, all you do is multiply the numbers under the square roots. So what's 5 times 20? 100. So now we got the square root of 100. Well, what is the square root of 100? So all of that simplifies down to just 10. Next one. What's this going to give us? Square root of what? Nobody knows.
What is it? It's 18.
Didn't we already do that?
Yeah.
Put that simplify down to
3 square root of 2.
3 times the square root of 2. So this, if you took your calculator and took the square root of 6 times the square root of 3, and then you took your calculator and did 3 times the square root of 2, guess what 2 answers you'd get? They'd both be exactly the same. On this last one, when you're doing something like this, you got numbers outside the square root and numbers inside. You multiply the numbers outside. What is 3 times 4? 12. So that's outside. That stays outside. On the inside, what's 5 times 15?
75.
Now, will that simplify any?
Yeah.
We already did the square root of 75. We did that way up here. What did it simplify to?
5 square root 3
So you got 12.
times 5.
And this, Riley better watch closely here, because what's going to happen is you do something like this, and then 5 times the square root of 3. Is that our answer? 125 times the square root of 3?
There's a multiplication symbol.
We're multiplying there. So outside, you multiply those two. What's 12 times 5?
60.
So you got 60 times the square root of 3. That's the simplified answer. All that simplifies down to just 60 times the square root of 3. On some of these, please make sure you read the problem carefully. Sometimes they want a decimal answer, sometimes they want an exact answer. What we've been doing here, all exact answers, not rounding anything off. So read the problem, know what they're asking you. If we're doing real life problems, if Branson's building his deck again, and he's trying to figure out how long, how wide it needs to be and stuff, does he probably want this answer? Probably not. That's not going to help him out in the real world. He's not going to tell whoever's measuring, hey, we need 60 times the square root of 3 on that side. They're probably going to say, we know
Where'd
that
you go to school at?
they probably already told him to go away, so it would never get to that point.
Why
but
would Branson be out there telling them what to do? Wouldn't they be telling him what to do?
Apparently not, because you heard him, he built it all himself, he said.
Stages and everything.
What did you do?
Nothing, I cut a fuse over.
I told you what happened earlier.
You should put more Tay-Tay on the slides.
He did one thing, and then they asked him to go.
Honestly, I worked on it one weekend, and then I went to my mom's every other weekend that day.
On purpose?
No, not on purpose. Those boys.
Fill in what you need to fill in on this. This was on the last set of notes, but we're going to go back over it again real quick.
How do I find a burger of a time?
Not tough.
It's a good song.
Okay, make sure you're keeping your binders in line. Don't make them a hard grade. I know I can say that 1,000 times, and some of you are still going to do the same thing. It won't matter, but I can always keep trying. For perimeters, pick a side in the first shape, compare it to whatever side it matches up to in the second shape. That should equal the perimeter of the first shape compared to the second shape. We already did this problem. We did it last time on the notes. Let's just set up the proportion here real quick, and we're not going to worry about solving it this time. Pick me a side in the first shape that matches up to the side in the second shape. 8 matches up to what? 3. Does everybody see that? This is what we're going to do a lot of on the homework. 8 matches up to 3. On the second one, the perimeter of the first shape. Somebody find the perimeter of the first shape for us. 45 matches up to, do we know the perimeter of the second shape?
No.
So we're just going to let it be P, and we're going to cross multiply and solve. We did that the other time. I'm not going to go through it again. All right, you can do that yourself. But no, it's just side from shape 1 over side from shape 2, perimeter of shape 1 over perimeter from shape 2. All right. The other theorem that we covered last time. Again, fill in what you need to fill in on this one. Circle that one when you get done, because that's the one that we want to use most of the time. We just got done doing a problem like this from last time's homework.
The first 16 questions are easy.
Same idea, all of them. So on this, you're setting it up, and again, I'm not going to do the example problem here because we did it last time. All you're going to do, area of the first shape, so area of shape 1 over area of shape 2 should match up to a side from shape 1 over a side from shape 2, but you got to remember in this one, unlike the perimeter, what do you have to do to each of these? What do we do when we do?
Square.
You got to make sure you square each one of those. Please don't make that little careless mistake. Make sure you square each one. All right? So if we were going to set this up, and I'm not going to solve it, we're just going to set it up. What's the area of the first shape?
120.
Area of the second shape?
We don't know, so, okay.
So A, side from the first shape,
10.
and we got to make sure that we do what to it? Square it, side from the second shape, and square it. So you're going to set that up, solve it. You probably want to do the squaring first, then worry about all the other stuff. Indirect measurements. On this, you got to have room there. There's going to be 3 things. So find this, and you're going to write down what I write down up here. There's 3 different things. First one, write shadow method 1. Make sure you don't write so big that you don't have space because there's 3 things that are going to fit in there. Shadow method 1. I mentioned this at the start of class. This is the stuff that out in the real world you can figure out. All right. I had a tree in my backyard, and that tree I left it growing because it was a nice tree when we built the house and everything. But it was a what kind of beetles did we have a few years ago?
Like, you mean like jumping?
No, the beetles that were eating the trees.
Beetles?
The birch or something, birch beetle or something like that. And there's certain trees that got ate up.
Oh yeah, ash. I know it.
Ash. Couldn't think of it. All right, so it was an ash. It's an ash tree, and it got ate up. And probably a good thing that I got rid of it because the wind that we've had here lately probably would have blown it over at some point. So it got ate up and it was really weak, and I had to have somebody come in and chop the top out of it. All right. I was hoping I could just cut it down myself, but what I did is I used this method right here, and I measured how tall the tree actually was by using what we're getting ready to do right here.
Yeah, really.
And I wanted to see, okay, if I drop this, is it going to fall? You know, if I don't get it, I'm not going to look like one of those stupid people on the video that think that they're going to yank this tree, you know, and pull it this way so it doesn't fall towards their house, because that doesn't work about 99% of the time.
They don't fall towards your house.
Right. You know, the tree's going to go the way it wants to go, whichever way gravity's going to take it. So, so I measured, doing this method, how tall the tree was, and figured out if it was going to fall and hit my deck or not and break my deck. And I figured out that it was, so I had to hire somebody to come in and do it. If it wasn't going to, then I was just going to cut it down myself and
You
go.
can put it other ways. You
Huh?
can put notches in it.
Can't you like just cut it from a certain side?
Like
Yeah, you just have breaks.
45 degree.
Branson could have done it.
Again, you guys, great ideas. The problem is, every time I see a video on TV where somebody's cutting down a tree and I know it's on TV, and I watch them, I go, stupid idiots, it's gonna fall on their house or whatever. All right? So, and I'm sure all those people do stuff like that, don't they? But then the tree decides, hey, I don't want to go that way, and it goes the other direction. Yeah. Michael, when you grow up and you have your own house, you do that. Make sure somebody's videoing it so that we can watch it on TV. Alright?
Yeah.
AFV, baby.
Maybe 75% of the time, maybe it works out just fine. It's that 25% that I didn't want to deal with where it happens to go back the other way. Alright? And I know it doesn't work just to make a V because my father-in-law had a driveway and he built his driveway around this big tree and it was right at his front door, about 15, 20 feet from his front door. And he cut the V in it. We hooked a chain up to it, way up as high as we could get in the tree, hooked it to a truck, pulling the opposite direction,
And it still went to the house?
and it still wanted to go towards the house.
Did it work? Did it go to the house?
No, we didn't hit the house, luckily. It fell sort of, we had enough on it that it fell sort of sideways and just missed the house. Killed a bunch of his bushes along the front of the house. All right, so try it, Michael. It'll probably work for you because you're Michael.
Nah, bro, Michael.
This is what I want you to draw on your paper. This is what I want you to draw on your paper. You got a person standing here. And that person has a what?
Shadow.
Shadow. Then maybe, I don't know, since we're talking about trees, draw a tree. You got a tree, it has a shadow.
It's a solid tree.
The sun shines on this, on both of them to make the shadow. And not only do they make the shadow, but what kind of shape is formed?
Their shape?
What kind of shape?
Triangle.
Two triangles. Guess what's true about those two triangles?
Sir.
They're similar to each other. Alright? The sun's always going to shine the same on this person as it does on that tree. Okay? And I know Kellen's trying to think of something silly right now, and he's going to say, well, what if the tree's in Richmond and the person's in West Manchester? Well, you're right. Then the sun's going to shine a little different on it. And it's going to be, does anybody know how far the sun is from us?
93 million.
93 million miles. It's going to be, what the difference is going to be here is going to be 1 over that 93 million. That's how much different those two triangles are going to be. So not very much. All right? So these two are always going to be similar. Hopefully, the person makes what kind of angle with the ground right here?
Right.
A right angle. The tree's going to make, I always have this argument with people every year too. Trees make what kind of angle with the ground?
Right.
A right angle. All right? Now, Cameron said back there, we got a tree and it's on a hill and it grows out sideways. No, if it's on a hill, if we have a tree on a hill, if this is our hill, the tree's not going to grow this direction. I'm sorry. Because what do all plants in the world try to do?
To the sun.
They try to reach the sun. So at some point, they grow out this way, and then what do?
They
Just start going.
They start going up.
So where's the 90-degree angle?
Now, on something like that, then you have to take that in consideration that you're on a hill, and then probably you wouldn't have to be able to do the shadow either, because the shadow is going to be
Shadow?
completely.
How do you draw a shadow to that?
So if we have this, now what I want you to write below this, we're going to set up our proportion. And I'm going to write this out in words, and you can just refer back to this every time so that you know how to set it up. First thing we're going to do, person. Now, does it have to be a person? No, it could be anything. But in this case, we put in a person. The person's height compares to
The tree springs.
the tree's height. What do you think is going to be on top of the second ratio? The person,
Person's shadow.
shadow, and it's going to compare to what?
Tree shadow?
The tree shadow. Every time, you're going to look at the problem, pick out the numbers, stick in what numbers you know, whatever number you're missing or you're looking for, that's going to be your variable. there's a shadow method one, that probably means that what?
There's a 2 and a 3.
There's a shadow method 2. Shadow method 2. A lot of students find this one a little more difficult. It's not really all that much harder. It's just a little more confusing, and probably what you're gonna have to do is split it up. I'm gonna draw it first here. We got our tree, and that tree has a shadow. Now, if you got nobody to help you, like I didn't have anybody to help me when I did my stuff, so this is what I did. I knew how tall I was, and I came out here on the tree shadow, and I stood on the tree shadow. So you got the person standing on the tree shadow. And what I made sure I did was I lined up my shadow, the end of my shadow, with the end of the tree shadow. And we still got our sun up here, and it's shining down on the tree and on the person. How many triangles in that picture?
2.
2. Alright, so there's still 2 triangles in there. You got the small triangle, you got the big triangle. The proportion, see this right here? Same proportion. So you're setting it up the exact same way as the other. The bad thing with this is, I'm going to throw some numbers in here. We don't know how tall the tree is. We know that Ebersole is 6 foot tall. We know that Ebersole's shadow was 7 feet long. And we know that Ebersole, when he walked out here, he stood 22 feet from the tree.
So you have to use Pythagorean theorem to find the angles thing?
No. What's my height?
6 feet.
What's the tree's height?
X.
What's the my shadow?
7.
Here's where you got to be careful. What's the tree's shadow?
29.
Why 29?
Because it's 22 plus 7.
All right, so to get the tree shadow, you had to add that whole thing there. All right, so it'd be 29. So you just got to be careful of that when you're using that shadow method too. Everybody think they can handle that?
Yeah.
Last one. Let's have it on here. Let's go with that. Last one. Mirror method. The mirror method. These are all called indirect measurement. They're called indirect measurement because we're measuring something indirectly. We're not actually taking a tape measure and measuring it. All right? We're measuring it indirectly. And these are things that you probably can't measure directly. You can't climb up in the very top of the tree and hold the tape measure at the top and have somebody hold the bottom, unless it's a sort of a small tree. You probably don't want to be doing that. All right? You can't, when back in 1969, when they sent people to the moon, how'd they know how much fuel to put in the rocket?
It's gas.
They just guessed. They said, you know what, we'll just put this much in there. Yeah, if I was just guessing and I was an astronaut, I might be a little scared.
Maybe they found out how far away the moon was. and
How'd they find out how far away the moon was?
They're
The
sending
mirror
some-
method. The shadow method.
They use something like the mirror method. All right? If you ever watch The Big Bang Theory, and at one point they shot a laser so that it would hit the moon and bounce back to them, and they calculated that time, they could calculate the distance after that.
That's cool.
All right? So what the mirror method does, I'm going to draw this picture. You got a person standing here. You got a mirror. That's your mirror right there. And then you got whatever you're trying to measure the height of. I'm going to draw a tree again. All right? If I was trying to measure the height of the clock there, what I do, I may have my mirror, no, there it is. What I do is I set the mirror down, and then I look in the mirror. Guess what I can see in the mirror right now?
The clock.
The clock. And I put it right in the middle of that mirror. So I'm looking straight down here at the picture of the mirror. If I was doing the tree, I'd want the top of the tree right there in the middle. All right? Then how many triangles do I have?
2.
2. And guess what's true about them?
They're similar.
They're similar. All right? So I'm looking at this, and I'm looking at the clock in the mirror. I can measure the distance I am from the mirror, the distance. We don't want the actual distance that the top of the tree is from the mirror.
We want the wall.
We want this distance, right? And I know what my height is, and probably I'm trying to figure out how tall the tree is, or how tall or how far off the ground the clock is. So when we set up our proportion, you're going to do person height, or whatever the height is. Again, it doesn't have to be a person, it doesn't have to be a tree, it could be whatever objects that you're dealing with. But here we're using a person. So person height, and what's the person's height compared to?
The tree height.
The tree height. Then on the other side, it's going to be the person distance from
Mirror.
the mirror compared to what?
The tree's distance from the mirror.
The tree's distance from the mirror. Good. So if I'm standing here and I'm looking at this and I measured, we used to go outside and do this stuff till I started buying new mirrors every year because some of my more intelligent students, as soon as Ebersole attorney's back, 5 minutes later I'd hear Jacob coming over to me going, "Hey, we broke your mirror, I don't know how it happened." And then I'd have somebody else tell me, "Yeah, they broke it because John, the idiot, was stepping on it."
So he really did break the mirror.
Yeah.
So was my name John?
Would you be the John? Would you be the cause that we can't go out and do this anymore? Because these mirrors, like this one that I have right here, I think this one cost me like $32.
What the?
I can't just go out. My wife gets upset
That's
when I spend
expensive
$32.
mirror.
No, it's not an expensive mirror. That's normal.
I mean, like, in general, that's just like a lot of money for a mirror.
No, well, you might think that, but that's about normal price for a mirror. They're very expensive.
Bro, just smelt some.
Do you go on
stuff.
Facebook Marketplace and trying to sell mirrors and stuff?
Basic money.
Why?
It's like they have to take
What?
a picture of
That's
the
a
mirror.
laugh, not a mirror.
I was waiting
for it. Yeah, but.
We got about 8 minutes left.
What's the name?
I thought I knew it was gonna say
That's glass, not mirror.
that. Yeah.
On the packet, if you didn't pick up the packet, grab it up here. On the packet, flipping through it, let's do a couple of problems together. Again, it's a long packet.
Let's do 17.
Some of them are not real hard.
They're all 17.
Number 17.
Oh my god.
Solve the following. Make sure to draw a sketch and show all the work. We'll probably have a quiz where at some point I'm just going to ask you to draw the pictures for me. It doesn't have to be a pretty picture, all right? So, but draw a picture and label it. If a 17. If a 4-meter flagpole casts a 6-meter shadow at the same time, a nearby building casts a 24-meter shadow, how tall is the building? So if I'm drawing this, first, when you're drawing these pictures, you don't have to draw the flagpole and the, if you want to draw them, that's fine. Draw 2 triangles or something, you know. What do we know? This, let's say this is the flagpole shadow, or flagpole triangle here. How tall is the flagpole?
4 meters. 4 meters.
So 4 meters. How long is its shadow?
6 meters.
6 meters. Then we got the building, right? Do we know the height of the building?
No, that's what we're trying to find.
So what is it?
X.
X? How about its shadow? 24 meters? Now all we're gonna do is come over here and set up our proportion. Tell me how to set it up.
4 meters over X.
4 compares to X, so this compares to that, the same as what?
6 over 24.
6 compares to 24.
Then you cross multiply.
We're gonna cross multiply. What do you get when you cross multiply this way?
6x equals
96.
96, everybody agree with that? Now what?
Divide each side by 6.
Divide both sides by 6, X equals what?
16.
What's 16? 16
X.
what? What's our units?
The height of the building.
It's the height of the building.
So 16 what? Inches?
Meters.
Meters.
16 meters. The height of the
What?
building is 16 meters. Is it alright for a building to be 16 meters?
Yeah.
I don't even.
How many feet is that?
How many feet is that about?
I don't know, maybe like 3?
So, remember, a yardstick and a meter stick are about the same, not
Yeah.
quite, but
So
about.
it's like roughly like.
So, how many feet are in a yard?
It's probably like 50 feet.
3?
It's probably about
Alright, so 3 times 16 is how much?
48.
Is it alright for a building to be 48 feet tall?
Yeah.
Yeah. Next question.
I mean, it's
The building should be 100 feet tall.
Next question.
19.
19.
on bait.
Juanita, who is 1.82 meters tall, wants to find the height of a tree in her backyard. From the tree's base, she walks out 12.2 meters along the shadow until her head is in position where the tip of her shadow exactly overlaps the end of the tree's shadow. She is now 6.1 meters from the end of the shadows. How tall is the tree? So we got our tree here. It's got a shadow. Juanita walks out here and she stops when her shadow matches up to the end of the tree shadow, right? Do we know how tall the tree is? So that's probably going to be our variable. Do we know how tall Juanita is?
1.82.
Yeah. 1.82 meters. Do we know how long Juanita's shadow is?
6.10.
6.10, 6.1 meters, is that good? Is that right? What else do we know?
It exactly overlaps.
That's true. What else?
She walks, that the tree to her is 12.2 meters.
Does everybody agree with that? So from here to there is 12.2 meters. We're going to set up our proportion. This is one I said some of you are going to have trouble with because you're just going to try to match up the numbers and it doesn't always work. What's the person's height? 1.82. What's that match up to?
X.
X. The tree's height, right? What's the person's shadow?
6.1.
6.1. Now here's where you got to be careful. What's the tree's shadow?
18.3.
Does everybody see where you got 18.3 at?
Yeah.
You had to add this whole thing. It's that whole length. All right? Now what are we going to do? Cross multiply. So 6.1 times x equals what? Somebody multiply this way for me.
306.
306.
Yeah.
Then what are we going to do?
Just divide by 6.1.
Divide by 6.1. Now they told you in the problem, they didn't tell you flat out, but they sort of did in the problem, how many decimal places to go out. How many places did they take all their numbers out to?
2.
They went out 2 places on every one of them, didn't they?
Yeah.
So guess what we should do?
2 places.
Go out 2 places. So what's our answer?
5.46.
Anybody else get 5.46? What's our units? Meters.
Which is
That's the what?
the height of the tree.
That's the height of the tree. Is it all right for a tree to be that tall?
Yeah, it's like.
What is it, like this tall?
18 foot.
5?
Like 19.
No pine trees.
It's like
What kind, again, listen to what Jacob's telling you. About how tall is it? 5 meters.
that.
16, 17 feet.
Don't listen to Branson. About 18 or 19 feet, 20 feet tall, somewhere around there. Your assignments, do the rest of them. I know it's long, but it's not very difficult.
I'll never understand what happens in period.
my thing?
I borrow that pen from my thing.
I am angry because I've been buying those pencils.
Me too.
They start to get expensive. I'm gonna quit buying it.
Yeah, I can't get there.
It's a resource, he says, he always says that for stuff, right? You don't have to do it, but I would highly recommend it.